Good morning, geometry fans. Great to see you again. Today we're going to talk about altitudes of triangles. Every triangle has three altitudes. An altitude is a segment that goes from one vertex to the opposite side, but it does so at a 90-degree angle. So sketch you a triangle that looks like the one I've got given here, triangle ABC. And then what we're going to try to do is sketch three segments from each vertex that would go to the opposite side being perpendicular. So I'm going to pause the video and sketch mine. So you'll notice in my triangle that I have three green segments now in it. Each of those segments is an altitude. Altitude basically just stands for height. And if you think about if you were going to measure how tall you are, you make sure and stand straight up and down. You'd want to be perpendicular to the floor to measure your height. And so segment BD, which we have drawn, is one of the heights of the triangle. And notice that it's perpendicular to side AC. And then segment CE is another altitude. It's perpendicular to segment AB. And segment AF is a third altitude, and it's perpendicular to segment BC. So each triangle has three different altitudes that could be drawn. One thing you'll notice about those three altitudes is that they all meet at a point. And we might call the point where they meet, we might call that point O. And you might recall from the last week when I had you doing some definitions that that point is called the orthocenter. So that's a pretty crazy word. Orthocenter is the point where the three altitudes of a triangle meet, and they will always meet at the same point, and that point is called the orthocenter. Now here's another triangle, ABC, and we want to see if we can figure out where its orthocenter is. Well, remember the orthocenter is where the three altitudes meet. And an altitude is a segment that goes from a vertex to the opposite side, but it does so perpendicularly. So we already have two altitudes in this triangle. Segment AB, this segment, is an altitude because it meets segment BC at a right angle. Segment BC is also an altitude because it meets segment AB at a right angle. So really the only one I have to draw is, I didn't do a very good job there. Let's try again. This guy right here. So if I draw that segment in, there's an altitude. Let's see. So we'll make that look like so. And I might call that point Q. And now segment BQ is also an altitude. And those three altitudes meet at this point B. So sometimes an altitude can be a vertex of a triangle. And in fact, in every right triangle, the orthocenter will be the right angle of the triangle. So in the first triangle, we saw that the orthocenter was a point inside the triangle. In the second triangle, which was a right triangle, we saw that the orthocenter was actually the right angle of the triangle. And here's an obtuse triangle. Let's put some labels on this one. So this will be triangle A, B, C. So this triangle is an obtuse triangle. The first altitude I want to draw a point from, or an altitude from point A and have it come down to segment BC. But the only way for it to be a right angle, I couldn't come inside the triangle and make it a right angle. So the first thing I'm going to need to do is I'm going to need to extend this segment out this direction a little bit. And then I could draw my altitude and make it a right angle right there. So altitude, we might call that AR. Segment AR is perpendicular to the line that contains segment BC. The altitude from point B is a little more straightforward. I would just go straight up this way at a right angle. So that altitude might be there, and we could call that point T. Then segment BT would be on altitude. And then if I wanted the point from, or the altitude from C, if I come back this direction, then I won't be at a right angle. So what I'm going to have to imagine is coming straight down this way and intersecting this line way out here outside the triangle. So I'm going to extend line AB, and then I might be able to imagine drawing an altitude this way. And then if you extend all three of these altitudes down, you will see that they meet outside the original triangle. Now this drawing gets kind of messed up, so I'm just going to shade the original triangle. Remember, the original triangle was this triangle ABC, and it's an obtuse triangle, and anytime the triangle is obtuse, then the altitude, or the orthocenter, will be outside of the triangle. So we've seen triangles that have an orthocenter on the inside of the triangle, triangles that have an orthocenter at the right angle of the triangle, and triangles that have an orthocenter that lies outside of the triangle.